Okay, hi. Today we're going to talk about a test called Osmotic fragility test. This test is not included in the Hematology 2. It is a part of Hematology 1. But since in Hematology 1 we did not have the time to do it last semester, we're going to do it this semester, and this is going to be the last chapter, and it will be it. There will be Hematology 2 will be finished. Hematology 2. Osmotic fragility test. This test is kind of not very often ordered, but when it's ordered to test the ability of the red blood cells to resist lysing when placed in a hypotonic solution. Let's go over what's hypotonic solution. Tonicity and three type of solution. In terms of tonicity, في عنا hypertonic solution, في عنا isotonic solution, وفي عنا hypotonic solution. Isotonic solution is a solution with sodium chloride concentration equivalent to 0.85% sodium chloride. That means this concentration of sodium chloride is equivalent to the concentration inside the red blood cells. Hypertonic, it's a greater than 0.85%, while hypotonic is less than 0.85%. Now, if we have three solutions, this is 0.85% sodium chloride, this is 0.7% sodium chloride, and this 0.2%, for example, sodium chloride. But this solution is called hypertonic, isotonic is an hypotonic. Hypotonic because the concentration of sodium chloride in this solution is less than 0.85%. Now, if we place red blood cells here and here and here, since this solution is hypertonic, as you may as well know, and we talked about it in biology, the water goes from the solution into the red often. The water goes from the cells outside to the solution, because it is inside the cells is 0.85, here outside is 2%, here is more concentrated than here. The water goes against down concentration gradient, which is from high to low. So the cells here in hypertonic solution shrink, looks like this, as it loses water. Here we have sodium chloride solution inside the RBC equivalent to 0.85, and outside in the solution here 0.85. So the water that goes on is the same amount of water goes in and out of water, the same exactly. So the RBC will stay the same. So it doesn't lose water or it doesn't gain that amount of water. Here, the opposite. Here we have 0.7% inside 0.85%. The water will goes from the solution, move, not water goes from the solution inside to the WBC. So what happened to the WBC here? Yes, it swells. It swells. It becomes bigger. Now, will it lyse? Will it burst? It depends how hypotonic it is. On a hypotonic solution is a solution that has a concentration less 0.85%. So 0.7% is a hypotonic, 0.6% is hypotonic, 0.2% and sodium chloride is hypotonic. Now, what happened when we put RBC in a hypotonic solution? This is what happened. The water goes from the solution into the RBC until equilibrium is set, or it bursts, or it lies. It depends how hypotonic the solution is. Most likely, if the solution is 0.7% is slightly hypotonic, the RBC will swells without bursting. But if the solution were, for example, 0.2% sodium chloride, this is a very hypotonic solution. In this case, the water will go from the solution into the cells. The cells grows bigger and bigger and bigger, and equilibrium will never be the same outside the cells and inside the cells, and the cells will lyse. So, we know what happened in those three solutions when we place RBC. Now, what it happened that not all the cells of everybody behave the same in a hypotonic solution. Some people, when we put the cells in a hypotonic solution, burst easier than others, or less resistant. Some people more resistant. So believe it or not, in this test, which is called osmotic fragility test, we're gonna place red blood cells in a series of tubes of hypotonic solution, and we see how much of these RBC burst, or how much of these RBC stayed intact or resisted the hypotonic solution. Now, it happened, this type of test, it has a clinical significance because in certain diseases like spherocytosis or hemolytic anemia, the cells, I'm talking about RBC, are less resistant to lysing than what? The cells of normal person who doesn't have a spherocytosis or hemolytic anemia. So it breaks easier. While on the other hand, people with thalassemia, sickle cell anemia, polycythemia vera, these cells here in these diseases are more resistant to lysing than normal RBC. So these, in another word, if we have three types of cells, a person here with spherocytosis has a spherocyte, here is normal, here sickle cells. If we put these are hypotonic solution here. If we put cells, spherocytosis cells here, normal cells here, and sickle cells here, in the same solution, we will find out more cells will rise here than normal, and less cells will rise here than normal. So spherocytosis is less resistant to lysing in a hypotonic solution than normal cells, while the sickle cells is more resistant than normal cells. So when we do the test, and if we find out that a lot of RBCs lysed in a hypotonic solution compared to normal, we should have a normal as a reference. Most likely, that person here will have spherocytes in his blood. Now, if we found it less, we'll have most likely thalassemia or sickle cell anemia or polycythemia vera. If we have the amount of our number of RBCs lysed equal to normal or equivalent to normal, well, the person doesn't have any of these diseases. Now, how do we do the test? Now we are doing the test, and how we do the test. As we said, we prepare a series of 10 tubes with 10 different sodium chloride solution. Now, we have, like you say, this is the table. It's in your manual. Tube 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In tube, we have buffered 1% buffered saline. We have distilled water, and we are gonna make a dilution. In tube number 1, we put 0 milliliter saline and 5 milliliter water. Yeah, here there is no dilution, 100% distilled water. Here, 0.5 milliliter of this, 1% saline, and 4.5 milliliter of distilled water. In tube number 3, 1 milliliter saline, 4 milliliter of water, and so forth. Tube number 5, 5 milliliter saline, 0 milliliter of water, mean no dilution. Now we made a dilution of this, different type of dilution. If we calculate the concentration of saline in these various tubes, we will notice that in tube number 1 is 0% saline because we did not add any. In tube number 2, 0.5 milliliter of saline with 4.5 milliliter of water. The final concentration will be 0.1%. The way we calculated, if you remember, C1 V1 equal C2 V2 before the dilution. After the dilution, before the dilution, أخذنا الفوليوم 0.5 milliliter, 0.5 milliliter, الكونسنتريشن إلى 1% equal the concentration final, we don't know, V final, إذا أخذنا this for example, 0.5 plus 4.5 will be 5 milliliter times 5. أصبح C2 1 times 0.5 over 5 will be 0.1%. And we do the same thing for the rest of the tube. So this is what we get. The tube number 1 is 0.0%, 0.1% saline, 0.2, 0.3, 0.4, 0.6, 0.6, 5, 6, 7, 8, and 1%. All these are, as you say, hypotonic. This is, the last one is hypertonic. Now, what we do next, in each of these tubes, we add to each of the 10 tubes, add 30 microliter of blood or patient blood. In this case, it's gonna be my blood. It's going to be what? My blood. We mix, we wait for 10 minutes, and we centrifuge, and we see what happened. Now, since, let's say we start with number 10. Since it's hypertonic, we don't expect any red cells to lyse, 0% lysing, because in fact the cell will shrink. While tube number 1, which is like the most hypotonic that is, which is 0% saline, there's no saline, the water goes from outside to inside the cell and it bursts. Sees 100% of the cells will burst. يعني عندنا 100% lysis, hemolysis. Here, still very hypo, more expect 100% losses. Here, maybe 80%, God knows. Many here or here, 0.5%, 36%. We should expect partial lysing of the RBCs and partial still the holding. So it depends, we will see. Now, after we add the 30 microliter of blood, we wait for 5 minutes, and we spin the tube. We spin شوية the tube. بنلاحظ هون, since 100% hemolysis, the supernatant will be red. Here, since no hemolysis, the supernatant will be clear. Will be what? Clear. And here, in between here, and then we calculate the percentage of hemolysis, how we measure the absorbance at 450 nanometer. The absorbance at 450 nanometer. Is it 450? Hold on. After we spin the tubes, as I said, we measure the absorbance here and here and here and here in the supernatant of these tubes at 540 nanometer. And we calculate, I'll tell you how we calculate the percentage of hemolysis, the percentage of RBC that had been hemolyzed in each tube. We expect here 100% hemolysis. We expect here 0% hemolysis. Now let's go to the experiment. Okay, we are going to start the experiment. It's called osmotic fragility test. So, to make a long story short, we prepared a series of 10 tubes from 1 to 10, like we explained. From 1 to 10, we added buffered saline and distilled water to each tube. So this is a 0% dilution, a 0% concentration, so it's saline, and the number 10 is 1%. This is 0.2, 0.1, 0.2, 0.3, and so forth. Now, to each of the tube, we have to add 30 microliter. Now, you noticed I don't have gloves on. I should, because this is my blood. This is my blood. Even though it's my blood, the rule it says we should always wear gloves. This is 30 microliter here, 30 microliter here. Accuracy is very important. We have to mix it. Maybe paraffin is better. We are mixing right now. And after we mix, We'll wait for 10 minutes. After 10 minutes, we centrifuge it for 10 minutes. If you notice, this is a clear number 1. This means it's 100% hemolysis. Here, it's a cloudy, mean the cells are not lysed because as expected, because this is hypertonic. Now, as it lies in these here, 50-50, and let's see how it goes, all right? Now, after 10 minutes has passed, we take it to the centrifuge. And we spin it for 10 minutes. After we spin it, this is what we get. This is a tube number 10. See how clear it is? 0% lysine. We expected. Tube number 8, 9, 0%. Tube number 8, you see, some lyse, some not. The same thing. If you go to tube number 1, it's 100% lysine. Tube number 2 is 100%. And tube number 4 and 5, 6, and 7, let's see, there's still some in the bottom. See, the number 6, there's some in the bottom. I mean, some lyse and some didn't lyse. So this is very hypotonic. Very hypotonic, 100% lysine. This is a slightly hypotonic, not 100% lysine. And he's hypertonic, of course, no lysine. Let's see. We start with number 10. We expect 0% lysine. And we do zero, and number 9, zero, number 8, zero point 0.2, and we will finish all through number 5, 6, 7, 8 to number 1, and I'll write on the board what we get. This is what we get for absorbance. In tube number 1, 0.632, tube number 2, 0.632, 3, 0.631, 4, 0.632, 5, 0.180, 0.155, 0.09 for tube number 7, 0.02, 0.00, 0.000 for 9 and 10. This is what it means, 0.00, we get no reading, there's no absorbance whatsoever, mean there's no hemoglobin, there's no lysine. And here the highest reading, the highest absorbance, number 1, and tube number 2, and tube number 3, and tube number 4. They are all the same. See, so for concentration of 0.3%, 0.2%, 0.1%, and 0% sodium chloride, they all lyse. They all show a lyse. That's 2 hypotonic. Now, 0.4% get less reading, mean some is lysed and some didn't lyse. 0.5% we have less reading, mean 0. May less reading, meaning much less for tube number 7 lysed. For tube number 8, because the concentration is hypotonic but not very hypotonic, we get very small reading. Now, how will we calculate percentage, how much hemolysis we get? Let's say for tube number 5, for example, tube number 5. This is tube number 5. We get a reading absorbance 0.182. So this is the formula, percentage hemolysis of tube number. We have put the tube number. Reading of tube number means the absorbance of tube number times 100 of reading of tube number 1. Tube number 1, because this is 100% hemolysis. This we compare it with tube number 1, because this is 100% hemolysis. Here, 100% hemolysis. Here is 0% hemolysis. So if we get a reading 0.632, mean 100% hemolysis. If we get a reading 0.00, mean 0% hemolysis. Now, the in-between will be, depends on how much hemolysis. Now, if we go percentage hemolysis of tube number 5 بيساوي reading of tube number 5, which is 0.180 times 100 على reading of tube number 1 اللي هي 0.632. If we have a calculator, we will get 28.4%. 28.4% of the cells lysed. Now, hemolysis of tube number 5 and number 6, for example, reading of tube number 6, 0.155 times 100 over 0.632 بيطلع عنا 155 divided by 24.5%. Now, how do we interpret the result? Now, along with a patient, we will have the same thing for a normal patient, and we compare the percentage hemolysis, for example, for tube number 5 for the patient and the normal reading for a normal person who has no anemia whatsoever, or tube number 6. Now, if, for example, tube number 5 for our patient versus normal. For our patient أعطانا 28.4% hemolysis. Normal أعطانا 45% hemolysis. Again, how we do the interpretation? We compare it with a normal patient, with a normal person, normal blood. Let's say tube number 5. Assuming our patient is 28.4% hemolysis. For a normal blood, when we took the blood, it's only 45% hemolysis. Mean the patient is less resistant to lysing because most of the blood lysed, only left often 28% lysed, mean a normal 45%. Mean the patient blood is more resistant. You mean what more resistant? Only 28% lysed, mean a normal person 45% at the same concentration. Mean this patient most likely has either thalassemia or sickle cell anemia. On the other hand, if tube number 5 for a patient 28.4% and for normal lysed only 12%, so here عندنا 28% lysed, هون عندنا 12% nice for a normal. See here, more cells get lysed, mean is less resistant to lysine. What it means, the patient has most likely spherocytosis, So in this case, either thalassemia or sickle cell anemia, and in this case is most likely spherocytosis. And this test, we usually use this test to check for spherocytosis. This is the most sensitive is for spherocytosis. Thank you very much.